Hello everyone. Today we're going to be talking about section 3.1, which is properties of linear functions and models. So in reminder, this is some of this will be review from the chapter 1 highlights where we dealt with linear equations. So the difference here is that before we were dealing with something like y is equal to mx plus b, and this is an equation, and now we're dealing with linear functions. So instead we will have f of x is equal to mx plus b. Now when we're dealing with functions, we also are not dealing with the vertical line or the x is equal to case. Say you have x is equal to 1. This equation is not a function, so we will not be working with that today. So remember when we have a line and say we have a couple of points on that line. This here is a linear function, f of x, and we can determine from either the equation of the line or the slope itself or the graph itself what the slope is of that line. So if I were looking at that, slope in reminder is equal to the rise over the run. And we can make a triangle in order to find it, or we can use the actual coordinates. So y2 minus y1 over x2 minus x1. Using the triangle here, we're rising 2 and running 1. So our slope here is equal to 2 over 1, or 2. Now the slope-intercept form of the line, just to bring that back in the front of your mind, using the equation, is y minus y1 is equal to m, where m is the slope, times x minus x1. And in this case, the 2 points, x1 and x2, where x1 cannot equal x2, so we cannot have a vertical line. Now we can identify the slope intercepts and the average rate of change between two x points using a linear function. So the slope, when we look at the line, this is f of x is equal to mx minus b, or plus b. So the slope itself is in the equation of the line. So here our slope is equal to 1/3. Our intercept point, we can locate the y-intercept by just looking at the b term when the line is in this form. So our y-intercept, the equation has plus b, so if it's negative, our y-intercept is equal to -3. And if I put that in an ordered pair, x is equal to 0, y is equal to -3. Now we can graph a line just using that. So I can plot that 0, -3 point here, and then we can count the slope in order to get to the next point. This is rise over run. So we're rising 1, running 3, and we get to our next point. Rising 1, running 3, gets to the next point. So here is a rough sketch of this linear function. Now we can find the x-intercept too by setting y equal to 0. So if we set the function equal to 0, I have 1/3 x minus 3, adding 3 to both sides, so 3 is equal to 1/3 x. Multiplying both sides by 3, I get 9 equal to x. So this is going to cross that intercept all the way down here. We also can model many real-world situations with some linear equations. So the relationship between, for example, the height of an adult male and the length of the humerus, x in centimeters, can be modeled by this linear function. H of x is equal to 2.89x plus 78.10. If the incomplete skeletal remains of an adult male include a humerus measuring 3.71 centimeters, approximate the height of the male. So if we're looking for height, what we're looking for is h of x, because this is a function of height. And that means that we have an x value that we can plug into this function. So if I plug that in, h of x is equal to 2.89x plus 78.10. Applied problems usually need some form of calculator for arithmetic, so 3.71. And 2.89 times 3.71, there's my x, plus 78.10. Simplifying the arithmetic here with my calculator, I have 2.89 times 3.71 plus 78.10 gives me a height of 88.82 centimeters. If an adult male is 175.3 centimeters tall, approximate the length of his humerus. All right, so now we know how tall he is, but we want to approximate the length of the bone. So this is our h of x, our height, and we need to approximate the x value. So I'm going to plug in this 175.3 as the height, and 2.89x plus 78.10. Subtracting 78.10 from both sides, 175.3 minus 78.010 gives me 97.2 is equal to 2.89x. Dividing through by 2.89, and I get 33.63 centimeters is the length of that humerus bone. All right, so you'll have a couple problems in the homework that are applied and a few problems where you're looking for the slope and the intercepts of a line. Let me double back for a second on that slope and intercept problem. Average rate of change between x is equal to 2 and x is equal to 4. There is a formula for average rate of change that we went over in Chapter 1. So from Chapter 1, the average rate of change is equal to the function at the second value minus the function at the first value over x2 minus x1. One thing to note, average rate of change is like a slope between 2 points. So when you're dealing with a linear function, the average rate of change is actually the slope. So our average rate of change here is m, or 1/3. All right, let me know if you have any questions, and I will talk to you again soon. Thanks.